Hello everyone, welcome back to another video. Today we will be doing bubble sort, spelled bubble sort. So this is the first type of sort you usually learn when studying sorting. And how a bubble sort works is, let's say we have a few numbers in an array. Let's just pick some numbers. Let's say we have 5, 2, 6, 3, 7, and let's say 1. So how a bubble sort works is we compare the first two numbers and see if they are in order. Are 5 and 2 in order from least to greatest? No. So we swap them 2 and then 5. And then everything else stays the same. So 6, 3, 7, 1. And then the next thing we do is we say, okay, 2 and 5 are now in order. Are 5 and 6 in order? Yeah. Are 6 and 3 in order? No. So we swap those and keep everything else the same. So 2, 5, and then we swap 3 and 6, and then 7, and then 1. So before we compared 6 and 3, and then we swapped them, now we go on to the next one. 6 and 7, are those in order? Yes. So we don't do anything. And then the last two, are 7 and 1 in order? No. So we swap them. So 2, 5, 3, 6, and then 1, 7. We just swap these last two numbers. Everything else stays the same. So now we've gone through the entire array one time. At the end of the first time going through the entire array, we know that the highest number is at the end. The reason for this is because we were swapping these two because 5 is greater than 2. So we wanted to swap these here, and then everything else stayed the same. And then we compare the next two. So 5 isn't greater than 6. So we kept that as is, and then we compared 6 and 3. Well, these are out of order, so we swap them. And then we compare the next two, 6 and 7. Those are in order, so then we compare the last two, 7 and 1, and then we swap them. Now, the reason the greatest number is at the end of the first time we go through the array is because if we had the 7 here, then we would have to swap 7 and 2, so 7 would be here, and then we'd have to swap the 7 and 6, so 7 would be here, and then 7 and 3 we'd have to swap again, so 7 would be here, and then maybe the 5 would have been here because I said this was a 7, so this would be the 5. So we'd swap these, and then 7 would be here, and then we'd swap these, and then 7 would be at the end. So at the end of the first time we go through the array, we have the highest number at the end. So 7 is the biggest number we have, so it is now at the end. Now we can focus on sorting the rest of this. So we can ignore the highest number because we know it's sorted. Then we can focus on the rest of it, and following the same steps, we'll get the second highest number over here. So let's start from the beginning and do the same thing we did, except we're taking what we have right now. So 2 and 5, we're starting back at the beginning. 2 and 5 is in order. Now 5 and 3, that's not in order, so we swap them. 2, 3, 5, and then everything else remains the same. Then we compared 2 and 5, that was in order. 5 and 3, we swapped them. Now 5 and 6, that's in order. So then 6 and 1, that's not in order, so we swap them. So 2, 3, 5, 1, 6, 7. So we swapped 1 and 6 over here, and everything else stayed the same. And then we compare these, and we're at the end of the array again. So now we know that these two are in order, because similar to how 7 was the biggest number at the end of the first time, we now have the biggest two numbers at the end of the second time. So then we follow our same steps using what we had here. 2 and 3 is in order. 3 and 5 is in order. 5 and 1 is not in order, so we swap them. So 2, 3, 1, 5, 6, 7. So we swapped 1 and 5. 5 and 6 are in order. 6 and 7 are in order, and we're at the end. So then the next part, we do it again. 2 and 3 is in order. 3 and 1 is not in order, so we swap them. So 2, 1, 3, then everything else stays the same. And then if we compare these, those are the same, those are the same, and those are the same. So now we had the largest number at the end, then we had the biggest 2 numbers at the end, then the biggest 3 numbers at the end. Now we have the biggest 4 numbers at the end. And so we've gone through the whole thing, and then we need to compare the first 2 again. So 2 and 1 are not in order, so 1, 2, and then everything else stays the same, 3, 5, 6, 7. And so we swapped these, and then everything else stayed the same. And then we need to check one more time. Is everything in order? 1, 2, that's in order. 2, 3, in order. 3, 5, in order. 5, 6 is in order, and 6, 7 is in order. So now that everything is in order, we know that we have a sorted array. So how do we put this into Java code? Well, first we need a loop to loop through the values of the array. So let's use the same array that we've been using. We'll say int arr equals, and then in our curly braces we'll put in our numbers. And then what do we want? We want a loop from the beginning to the end of the array. So for int I equals 0, I less than arr dot length, and then I plus plus. So we want a loop that goes through the entire array, but we also want another loop. We want to go through the entire array multiple times, because over here we were doing some comparisons, but then we started back from the beginning over here doing comparisons again, and we started back from the beginning over here doing comparisons again and again and again. So we want another loop to continue doing comparisons. So we'll say for int j equals 0, we need a different comparator variable here. Usually if you have multiple loops, you want to have I and then j, and then if you need another loop, usually people use k, but we'll use j for the second loop. And then what do we want j to be less than? Well, we know that at the end of the first time we go through it, the largest number is at the end. So we want to go up until, so this was the first time we did it, or the 0th time we did it. The 0th, the first. So at the 0th time, we want to go to the 0th from the end. And then from the first time, we want to go from the first time from the end. Usually we'd say 2 is at the 0th element, but if we reverse this array, then the 7th is the 0th from the end, you could say in quotes. So then 7 would be the 0th from the end, 6 would be the first from the end. So we want to go to less than array.length minus I minus 1. And we don't want to go to the length, we actually want to go to the length minus 1, because we need to do our last comparison here. So when we do our last comparison, we want to stop here so that we can compare with the next one. If we stop here, then there's no next value to compare it to. That would be out of bounds. So we want to stop at 1 before the end, which is why we put the ending here. And then this one, we want to stop it at 1 before, or I'll rewrite this to 1 over here and I over here, so then it's a little bit more clear. We want to stop at the end, but we want to do minus 1 because because there is nothing after the last one to compare it to. And then we want to do minus I because we know that the last one by the end of the first time will be the greatest, and then the last two will be the greatest, and then the last three will be the greatest, the last four will be the greatest, the last five will be the greatest. So that's why, and that 1, 2, 3, 4, 5 is controlled by the I. It's controlled by this I. We want to stop the comparing once we know that everything after this is going to be the greatest number sorted. So then we just j++ as our increment. And then what do we want to compare? Well, we're inside the j loop right now. So what we want to compare is the j. We want to say, is array at j, for the first time it'd be j is here, so j is j less than j plus 1. The reason we want to do that is because we start at int j equals 0, so that's right here. And then if we compare it with this, then we'll swap it. So if ARR at j is greater than ARR at j plus 1, then we want to swap it. Swap the values. So let's see how this would work. We'll come back to the swapping part later, but let's see how this will work. We'll have an int j equals 0 to the j dot to up to array dot length minus 1 minus I. So the I is 0 right now. So let's see what that looks like. If we have j 0, this is different, so we swap. So then we get this, and then we do then we go to the next. Now after the swap, the j is 1. Then we compare. Because we compared, then there's no swap, so now j is 2 compared to 3. Well, yeah, we need to swap these, so we swap these. And then j is 4 compared to 5, we don't swap, now it's 5 compared to 6, we swap. So now we have gone through this section. We've gone from j equals 0 to j at array at length minus 1 minus I. The minus I in this case was 0 because we were in the first loop of here, so we can just ignore this for the first part. Now I becomes 1. We I++ and I becomes 1. So now we're over here where I equals 1. I'll make this clearer. Let me put I equals 0 for this part. And then this part is the I equals 1 part. So our stopping part is going to be right here. So what we do is we say, okay, these, when we get to I equals 1, we start over at j equals 0. So we're starting back at the beginning. So j equals 0, we compare, we say, is 0 greater than 1? That's this. Is array at j greater than j plus 1? So is 0 greater than 1? No, we don't swap. Is 1 greater than 2? No, we don't swap. Is this greater than that? No, we don't swap. What about this? Yes, we do swap. And this is the last one we compare because our stopping was right here. We stop here, so this is our last comparison. And our last comparison we swap. So now we go to I equals 2, and now our stopping place is going to be over here. So then we say, is 2 greater than 3? No. 3 greater than 1? Yes. So we swap. So when we swap, we get this, and then we swap, and then we say, is 3 greater than 5? Well, no. And then this is our finishing condition. So I should have actually moved this up 1. And then we get to I equals 3. Then we have the 2 and 1. So our stopping is 1, 2, 3. So our stopping would be here. So is 2 greater than 1? Yes, so we swap, and then we stop right here and we're done. So that's how these first 3 lines work. Now, how do we actually swap the values? So when we're swapping values, let's say we have values 4 and 2, and we want to, let's say these are in the array and we want to swap them. So we have array at, let's say this is an example where we have a length to array and we want to swap them. So array at 0 is equal to 4, and array at 1 is equal to 2. So what we want to do is we want to set array at 1 equal to 4 and array at 0 equal to 2. But we need a temporary variable. So our temporary variable, we could say int temp equals array at 0. Now we are holding the value of array at 0 in temp. And then we're reassigning, we can now reassign array at 0. Because before, if we reassigned array at 0 first, we would lose its original value. We kept its original value in temp. So now we can reassign 0. So now we can say ARR at 0 equals ARR at 1. So ARR at 1 is still ARR at 1. We have not assigned it to anything. We have assigned ARR at 0. And its previous value was held in temp. But ARR at 1 still holds its value. So now, since ARR at 0 is now equal to ARR at 1, which is 2, so in this line, we can show that ARR at 0 equals 2. Because ARR at 1 equal 2, so ARR at 0 is now equal to 2. And over here, we can say that temp equals 4. So temp is now equal to 4, and ARR 0 is now equal to 2. Now we can reassign ARR at 1 is equal to temp. The reason for this is because temp held the value of ARR at 0. So now ARR at 1 equals 4. Before ARR at 0 equals 4, ARR at 1 equals 2. Now we have ARR at 0 equals 2 and ARR at 1 equals 4. So that is how we swap the values. So rather than using these numbers and these values over here, using our j values up here, we can do the same thing with the temp. We can say int temp equals ARR at j, and then we can say ARR at j equals ARR at j plus 1, and then we can say ARR at j plus 1 equals temp. So this is how we can swap the values. So this is how the swapping part works, and I already explained how these conditions work to actually go through the array. So now this is our for loop, the outermost for loop. So we want to print after this loop is done. So we print out here system.out.printf %s, and we want to do arrays.toString ARR. And remember, to use arrays.toString, we have to have this import java.util.arrays. So let's see if we did it properly. Let's run this, and we get 1, 2, 3, 5, 6, 7 sorted in order. And our original array was 5, 2, 6, 3, 7, 1. So we have 1, 2, 3, 5, 6, 7. This is how we can sort arrays in Java. You will come across more sorting techniques later on that are more complex. This was probably complex already, but there are even more complex ones. So in this example, we did the bubble sort. This is called the bubble sort. And the bubble sort compares the adjacent values, which means the values that are right next to each other, and swaps them. By the first time we get through the array, we have the highest value at the end. And by the second time, we have the two highest values at the end. And then so on and so forth. 3 highest, 4 highest. So once we have the highest values at the end and we're going back to the beginning, then by the end of it, we will have it sorted. That's how bubble sort works. In the next video, we will be talking about matrices.